All right, happy Friday. Today we're winging it today. The sun is shining. The snow is melting. I saw a flock of chickadees yesterday when I left, and it excited me. And every day in the morning I come in and there's a cardinal that greets me at the door. It's my cardinal call. All right. So here we go. Today we're going to talk about standard deviation, variance, and what these two things measure is a measure of spread, like how spread out your data set is. So we have a very simple couple of data sets to get an idea of what this means right off the bat here. Okay, so these two data sets, 19, 20, 21, and 0, 20, and 40. Let's calculate the mean quick of these data sets. Not 40, nope, it's 20. So that if you add up 19, 20, and 21, you find the average. If you just think about it, the average. Okay, so the average here is going to be 60 divided by 3, which is 20. And then the average over here is also going to be 60 divided by 3, which is 20. So the mean is both 20 in both data sets. And the median is also the same. So these are just some neat, fun little data sets. There's only 3 values. But they're very different data sets, right? They're very different sets of numbers. So one of them is more spread out than the other. Which one's more spread out than the other? The blue one. Good. So we are going to learn how to calculate a metric today called the standard deviation. And the standard deviation essentially is going to tell us about what the average distance from each element to the mean is. Okay? So if we just kind of get a feel for what the standard deviation would be, it would be like the average distance from each element to the mean. So like in this first one here, I'm going to go kind of rogue here a little bit. But in this first data set, let's just say, what do you think the average distance from the mean is here? All right, if I calculated that, how far away is 19 from the mean? 1. Okay, so it's like 1 plus, how far is 20 away from the mean? 0, it is the mean. How far is 21 away from the mean? 1. Okay, the average of those divided by however many there are is 3, would be like 2/3, or like 0.6 repeating. So this is more or less the concept of standard deviation, is like it's a number that indicates on average about how far away is each element from the average, the middle, the mean. Okay, and in this case, each element on average is 0.6 units away from the mean. Okay, over here, it's going to be a much bigger number, right? So like, how far is the average distance from the mean here? Well, you'd have 20 plus 0 plus 20, which is going to be 40 divided by 3, and 40 divided by 3 is going to be 13 1/3. So 13.3 repeating is about on average how far is each element from the mean here. So this isn't how you exactly calculate the standard deviation. It's a little more complicated than that, and there's a little bit of kind of a backstory with how that calculation how they came up with that. But more or less, the standard deviation is a measurement of like how far away on average is each element from the mean. So the standard deviation for the blue data set is much bigger than the standard deviation for the red data set because that data set's more spread out. Okay, it's more spaced out. Make sense? So I'm going to show you how we actually calculate this standard deviation number. Here are some kind of definition type things. So we have, if you want to read up on that, measures of variation that we use are the range, interquartile range, and then the new ones today are variance and standard deviation. Variance is denoted by sigma squared. So we use a little Greek letter to represent the variance, and the square root of the variance is what is going to be the standard deviation, which is denoted as sigma. So yeah, sounds like a fraternity. Yep. Yep. So there we go. Let's pop over to the next page. Here's the process. This goes through the process of how you find the standard deviation. And first thing you do is you have to find the mean. Then you find the difference between each value in the mean, kind of like what we just did. But if you subtract the mean from each thing, or if you subtract the mean from each value, you're going to get negative numbers. So that's where the problem comes in, and that's why we end up having the squared and square root and all this stuff. Okay. I'm going to pop back to the first page there. So what I actually did when I found my differences is I made sure they were all positive, didn't I? So when you actually calculate the how far something is from the mean, you would either have to use like an absolute value to make it positive, or you'd get negative numbers. And the reason that they didn't use absolute value is because it's kind of hard to manipulate algebraically. So really what I did here is I did, I would have done 19 minus 20, and that would have been a negative 1. And then here I would have done 21, well, I would have done 20 minus 20 there to get 0, right? And then I would have done 21 minus 20 to get 1 there. And so really, these negative numbers, when you subtract the mean from each element, creates a problem, because if I add all of these up, like negative 1 plus 0 plus 1, I would get 0 every time. In fact, every time if you subtracted the mean and you found the average from all of the data points subtracting the mean, you'd get 0 every single time. Okay, so that's why we have this complicated process with these squares in it, because they squared each element's difference to get rid of the negatives. Okay, so we'll go back to this complicated process page where it's like, here you're going to find the mean, then we find the differences between the mean and each value, and then we square them, because if they were negative, we wouldn't get anywhere. We'd just be spinning our wheels. So we square them, and then we add all the squared differences up, which basically we're just doing that to find the average of them. So we're finding the average of all the squares of all the differences between each element and its mean. Say what? Yeah, you heard me. Okay, so let's do it and you'll get a better feel for it. So next page, we have a little bit of a data set cruising here for some sort of bus stops. Okay, and we have a nice table that Mrs. Smith organized. And so let's fill this table out. Here we have 6, 7, 8, 5, 10. 6, 7, 8, 5, 10. 6, 9, 8, 4. Okay, there's all of our elements in our set. There's 9 of them. Okay, we need to know the mean. So if you add all those up and divide by however many there are, you would get a value of, I remember this from the previous 2 hours teaching it, you'd get a value of 7. Okay, so the mean of this data set is 7. All right, so now we need to find the difference between each element and 7. So I'm going to minus 7 from every single element, and that's going to give me a difference of the element and the mean. So 6 minus 7 is negative 1, 0, 1, negative 2, 3, negative 1, 2, 1, and negative 3. So some of them are positive and some of them are negative, and that's why we have to square, because if you were to find the average of all these numbers, you know what it would be, Kate? 0. Good, nice job. Yep. So 0 is not going to get us anywhere, so now we got to square all these numbers. So let's square them, and I'm going to get square negative 1. I get 1, 0, 1, 4, 9, 1, 4, 1, 9. Muy bien. Good. So now we squared all those numbers, and so now I'm going to find the average of the squares. So I'm going to find the average of all those, means I have to add all those up. And when you add all those up, you get, I believe, 30. Okay. So, do you get 30? I don't know. Now I'm second guessing. Okay, so now you get 30. So now what we have to do in order to find our, this is going to be finding our variance. So we're at step number 4. If I'm going to cross these, you like crossing stuff off? We did that. We did that. We squared the differences. We added them all up, and now we need to divide by however many there are. So now this step is going to take 30 and divide it by 9, right? Okay, so 30 divided by 9 is going to give me my variance. That's my sigma squared is equal to 30 divided by 9, which is 27. It's going to be 3.3 repeating. Yeah, decimal's good, yep. So that is your variance, which is your sigma squared, right? Okay, now that's we're on our way. We're not quite there. Now, in order to like how can you undo all the squares? Because I really don't want to know what the squares are, so I want to kind of undo that part. So how do you undo a square? Square root, yep, square root. Okay, so now I'm going to take the square root of that variance, and the reason why I'm doing that is because I didn't want the average distance from the mean squared. I want the average distance from the mean. So to undo that, we are going to take the square root of 39ths, and you put that in your calculator, and you end up with something. 30 divided by 9. Bam. Second square root, second answer, 1.83. That is the standard deviation. Yeah, there it is. So what does that number represent, more or less? Oh, come on, that's what I just said. What does the standard deviation represent? What is it telling you about your data set? Yeah, you watched all this last hour, Turkey. The average, it's basically, it's the average distance from the mean, all right? It's not exactly the average distance from the mean because we had to square it and then unsquare it. And so that created like not exactly the average distance from the mean. If you wanted to actually find the average distance from the mean, you would have to use the absolute value like I did on the first page, but absolute value doesn't play nice within some algebraic manipulations, so that's why they went with squares. Okay, let's have you try another one here, and then we'll wrap this up. Find the mean, variance, and standard deviation again. This one's probably going to be a little bigger standard deviation because the data set is a little more spread out, don't you think? Okay, so I'll give you a minute and a half head start, and then we'll see if your result matches my result. All right, you should have done that after a little pause, a little posky there. And you pause, and this is what you got. So hopefully you got a standard deviation 7.24, variance 52.4. So this is a little bit bigger, and the bigger the standard deviation, the more spread out your data set is. I'm going to ask you one more follow-up question here. Okay, so let's see if you guys are understanding this. I'm going to give you a data set, so I want you to stop and just think about this data set. Ready? Yeah. All right, here's the data set. Okay, remember this. Okay, so you got to think 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. Did you get that? Okay, what is the average, the mean? 5, good. What's the difference between every element? And she actually wrote it down. The difference between 5 and every element in that data set? 0. Add all those zeros up. What do you get? 0. Divided by however many there are. What do you get? 0. Oh, sorry, I forgot. Square them. 0. Add them, divide them by however many there are. 0. Take the square root of 0. What's the standard deviation? Right? There is no, none of them deviate. They're all the same. You know? So the smallest standard deviation you could have is 0. And what that would mean is that all of your elements would be the same exact number. No, they would be all the same. No, they don't deviate at all. There's no deviation at all from the average. All right, so the greater the standard deviation, the more spread out your data set is. And that, my friends, is what standard deviation is. All right, under 15, way to go. Happy Friday. I want you to go out there this weekend. I want you to grab a lawn chair. I want you to sit back and watch the snow melt. It's going to be relaxing while watching the video.